sum of a sequence, which of course is series. You remember I said series technically is when we add up all the terms in a sequence. So let's have a look at that. Notation. So when we add up the first term, which I've called term 1 there, plus term 2, plus term 3 up to term n, yes, we can write it as Sn, but we could also use the sigma notation. So when we use the sigma notation, we're just saying we're going to sum up and then we just have the general term there. So all the terms that fit this pattern going from, and in this case it would be from the first term to the nth term. So here's an example of that. It is of course an arithmetic sequence. You'll hopefully recognise that anyway. A linear function as a general term will always be an arithmetic sequence. So that's a linear function. Well, a little bit later we'll find out a formula, but at this stage, and that's why I've only gone from 1 to 5, we could substitute in, work out each individual term and add them together. Oh, well, there you go, it's 45. They've told me the sum to 10 terms is 29 and the sum to 11 terms. So a little bit of logic, we can work out the 11th term, because if you think about it, the 11th term must be the sum of 11 terms minus the sum of 10 terms. If we take away the sum of 10, we must be left with the 11th term. So the 11th term would simply be 8. So that way, we could do the same thing. If they gave us a formula for the whole series, so the sum to n, we could work out the general term using the same idea. The general term would be the sum to n terms minus sum of n minus 1. So 5n squared minus 2 minus, well, everywhere I see an n, I'll replace it with n minus 1. All right, bit of algebra from there, and there's our general term, 10n minus 5. And then we could work out any particular term that we needed to. Okay.